Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is Amirakin bin Hushaini. Me and my teammates will present to you about our machine learning project with it, which is cats and dog recognition. So without further ado, let's go. So for group members, we have me, Amirakin bin Hushaini. We have Aiman bin Abdul Kadir, and we have Muhammad Amir Ashraf bin Roslan. Introductions. Today, facial recognition and object recognition are widely used in our society. People have used a lot of recognition for learning reasons, and it is easy to access as you don't have to type or write anything all over. For our group project, we have decided on cats and dogs recognitions. We are creating a system that will differentiate a picture of a dog and a cat. The cats and dog system are based on image processing that has been developed. Moving on to problem statement. It is hard for a computer system to recognize cats and dogs because they both have similar features. For example, they both have four legs, they have whiskers, they have ears, and also they have tails. So, for our objective of this project is to train the machine in classification of binary class data. Second, to identify the best optimizer to train neural network. Lastly, to predict the correct images from the datasets. For our scopes, it is animal, which is cats and dogs. Moving on to data analysis, the data of cats and dogs recognition is obtained from Kaggle. It contains 9,000 images of cats and dogs five with 5,500 of those images is cats. Meanwhile, another 5,500 is a picture of a dog. The original image in the dataset varies in pixel sizes. It is required to be pre-processed before being fed to the model. Pre-processed that have been used in our datasets are resize and grayscale. Grayscale. So what is grayscale? Grayscale is a collection of all the range of monochromatic gray shades ranging from pure white on the lightest end to pure black on the opposite end. Grayscale only contains luminescence, which is brightness information, and no color information. That is why the maximum luminance is white and zero. Luminance is black. Everything in between is a shade of gray. That is why grayscale image contains That's why grayscale images contain shades of gray and no color. For our picture, it is RGB image and it is consists of three layers, red, green and blue. While grayscale only has one layer contain value from range between 0 to 255. RGB is not required to determine cats and dogs. And resize. The image will be resized to 50 by 50 pixels. This is to reduce the input size and time taken to be trained. After that, the dataset enables us to make the recognition of cats and dogs and turn it into a pixel format. For the input layer, it contains the input of 50 by 50 for each pixel.
My name is Muhammad Amir Ashraf bin Roslan, and I'll be explaining about the ENN structure for our model. For our dataset, I think the most suitable machine learning method that we can use is the convolutional neural network, and then feed it to multi-layer perceptron. The why CNN is suitable here because our dataset is in image, so CNN allows us to take the features that distinct that later will be fed to MLP. So here our CNN structure, we have the first layer, we have the convolutional 2D, and then we activate it using ReLU function, and then we have max pooling 2D. For our second layer, we have convolutional 2D again, and then we have second activate, that is ReLU function, and then we have max pooling, and then we be flatten it from the 3 dimension to 1 dimension, I think, and then we will be dense it twice, and then we will be fed to multi-layer perceptron using sigmoid function. So the structure that we had chosen was 50 times 50 input, where every pixel which total to 2500 input. The output must be only one output, and there were two possible outcome, either it was cat or dogs. Wait. So here. So for our hyperparameters, we set our epoch to 2020 and our batch size is 32. Our validation speed is 0.1. That's mean 10% will be the validation set and 90% will be the training set. Our learning rate will be default. The momentum value also will be default. The only we change here is the optimizer. We have 5 optimizer that we use, which is Adam and Adam, uh, Adagrad, Adamax, and SGD. So we try to find which one is more accurate from these 5 optimizer. Others will be fixed. So for the experiment was conducted by using dataset of 5000 images of cats and dogs. Like I said before, the validation speed is 10%. That means 4000, 90% of it will be training set and 10% of it will be validation set. So for the optimized Adam, this is our result of our model. And then this is for the Adam. This will be the Adagrad. This will be Adamax, and this will be SGD. All of this graph, all this model, we have trained it one by one. So here the summary on the optimizer here. You can see the accuracy and val accuracy is doesn't have like very large difference. If it is very large difference, it will be overfit, and if it is too close to each other, it will be underfit. So for the each optimizer, we can see that it is okay. After that, after we have trained, then we will be test the accuracy for it. Based on this, we can see that the best one will be an Adam with 96% accuracy, followed by Adamax with 95%. The least accurate will be Adam optimizer with 49% accuracy. So for the parameters, or for the parameter that we use, just like I said before, for the CNN we use the ReLU function for the first layer and the second layer, and then for our multi-layer perceptron we use the sigmoid. The reason why we use ReLU is the model have a better performance and easy to train, where the sigmoid we use it for model where we need to do the prediction of the probability as output. So the sigmoid is for the classification of the output. So sigmoid sense exists in anything between range of 0 to 1. Sigmoid is the best activation to determine our output. So that's it for the ENN structure.
For the results, I will talk about the response time, memory usage, and the epoch. The, for response time, the accuracy of the datasets is 96.04% because all of the pictures in the datasets are all images of cats and dogs, and the response time to complete the test data only took around 55 seconds. For memory usage, the data is saved automatically to disk from the notebook and can be reused for future use by someone else. And Anaconda Jupyter optimized the execution process. Second one, all of the images of cats and dog are real image and loaded from the datasets. Third one, the train folder would save about 100 megabytes of the memory usage. Lastly, epoch, uh, network reach 97.21% accuracy within 20 epoch. As you can see below, uh, the first one is the result of one for one time epoch, and for the last one is the result after being run 20 times. Next, advantage and trade-off. Since our training is used a total of 9,000 images of cats and dog for the machine to differentiate between cats and dog, all in our datasets with many inputs. The images were converted into pixel form of 50 times 50 for the input, which makes our training slower for the first run. To achieve much higher accuracy of training data up to 97.21% and the accuracy of the test data up to 96.04%, we need to increase the epoch value to 20. Even though it takes a lot of time to finish 20 epochs of our training, it worth it because we achieve a much higher accuracy result than run it by one epoch. The accuracy of the training data increased by 29.96%. That's what we need to sacrifice in order to achieve much higher training accuracy. In conclusion, to achieve high test data accuracy, we need a lot of images in the training data process. We use a total 4,500 and 4,500 for cats and dogs images in our training data process. We achieve 97.21% of accuracy in the train data process and 96.04% for test accuracy. We can conclude that for our dataset, it is suitable to use Anadem optimizer rather than other optimizers such as Adam, Adamax, SDG, Adagard with the highest result of the train accuracy. That's all from our group. Thank you very much.